Okay, so just a couple of examples here kind of leading us to long division of polynomials. First thing will be to sort of remember how we do long division with numbers. And so assuming this is our question, in the good old days back before we had calculators, we would do something that looks like this. And the question we ask ourselves is basically, what does the 64 divide evenly into? Or how many times does it divide evenly into sort of the numbers as we go across here? So 64 will not divide into the 8, but 64 will divide into the 81 exactly one time. And then we multiply 1 by the 64, write that down here, and subtract to determine kind of what we're going to move forward with. So that's 17. Subtract the 9, then comes down. And we're wondering how many times 64 goes into the 179. It will go only twice, and that will be 128. Subtract again, 51, and now the 2 comes down, and that should go 8 times. And we multiply 8 by the 64. We have 8 times 4 is 32. 48 plus the 3 is 51. And 0 remainder. Okay, so something we haven't probably done much, or you probably haven't done much since grade 4, grade 5, is worrying about the remainder. That will come into play in the next little bit, so it's kind of important to recognize that when these numbers divide evenly, we have this 0 remainder. So, we want to do the same thing with polynomials now. Give myself a bit more room. This will take a bit more space for sure. So we'll write it the same way. We're looking to divide this by the x minus 4. So we're going to rewrite this in this form with our long division symbol. Ooh, that was not good. And now the question is exactly as it was before. We're looking to kind of focus on the larger term here, or the exponent, the term with the larger degree. Here 60 was more important than the 4. Here x is more important than the negative 4. And so I'm looking to determine how many times x divides into this term. And of course it's going to be 2x cubed times. And as I did here without even saying it, kind of lined up my hundreds with my hundreds and so on. It's an even better idea now to keep this lined up in terms of identical terms. So x minus 4 dividing into this will go 2x cubed times, and now multiply through exactly as we did before. 2x cubed times x is 2x to the 4th. 2x cubed times negative 4 is negative 8x cubed. And that's just kind of the way it worked out in this question. Certainly we won't always get the same values. 2x cubed, sorry, now I'm subtracting 0. This gives me 0, and this time it happens to give me 0 as well. Again, it won't always. So 8x cubed minus negative 8x cubed is 0x cubed. The 6x squared comes down. And now what I'm looking at is this term. Okay, so I sort of chose this example for a reason. If you have the 0x cubed, you still need to deal with it. We can't skip over it. So we're interested in knowing how many times does x divide into 0x cubed? Well, 0x squared times. Multiply these through. 0x cubed, 0x squared. And when we subtract negative 6x squared minus 0, we get negative 6x squared. 32x comes down. And we're interested in how many times does x go into this. And so it's negative 6x times. Multiply through, I've got a 24x. And again, negative 6x squared. Subtract one more time, 0 here. 32x minus 24x is 8x. The last 32 comes down, and we have plus 8 on the end here. Eight x minus 32, subtract 0, remainder. So what this is telling me is the original expression divided by x minus 4 divided perfectly evenly because there's no remainder. Now just sort of a quick point in here, you probably noticed that by including the 0, sort of worrying about the 0x cubed, I really didn't do much. My expression here was negative 6x squared. The expression I ended up working with in the next part was negative 6x squared, and I ended up with a 0x squared in here, which means that really it didn't serve much purpose. I could have jumped ahead to this next part and just written my negative 6x down, kind of left a blank spot there. I think initially dealing with the zeros is important, and certainly if you had a 0 in here, if this happened to have been 22x to the fourth minus 6x squared plus 32x minus 32, and this term was not written in, you would want to put plus 0x cubed in just to make sure you keep things lined up. I think it's a good idea to have this in here at this point to make sure things you don't miss anything, but it does turn out that it isn't necessary. And so what that means is, at the end of this, 2x to the fourth minus 8x cubed minus 6x squared plus 32x when you divide by x minus 4, what you get is the answer 2x cubed minus 6x plus 8. Okay. For our purposes at this moment, that is what we need to know.